Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance, and today we are looking at bond enthalpy. We're asked to calculate the bond enthalpy for the formation of water as our first little project. And over here, I have a table of average bond enthalpies. So let's get started. So the first thing you're going to want to do is write the chemical equation for the formation of water. So we have diatomic hydrogen plus diatomic oxygen is going to yield water. And we just need to balance this equation, edit. And we just need to balance this equation, and it's balanced. Okay, so we have two different types of bonds in the formation of water, and we have actually three different types of bonds. We have a hydrogen-hydrogen bond, we have an oxygen-oxygen bond, and we have an oxygen-hydrogen bond. We have two oxygen-hydrogen bonds per water, and one hydrogen-hydrogen and one oxygen-oxygen per diatomic hydrogen and diatomic oxygen, respectively. So for hydrogen-hydrogen, that is, if we look down at our chart, find hydrogen-hydrogen, which is right over here. We need 436 kilojoules per mole. So 436 kilojoules per mole. And there are edit. And there are two instances of this, because for each instance has to do with one diatomic hydrogen, and there are two diatomic hydrogens in this equation, which gives us a total of 872 kilojoules per mole. Next, we have oxygen-oxygen. And again, we have to locate that on our chart, which is right over here. So we have 146 kilojoules per mole. We don't have any multiplier for it because there's only one oxygen-oxygen bond in the formation of water. So the last one we have is oxygen-hydrogen. And we just need to locate that. And we actually covered it up in the last go round. It's right over here, 463. So 463 kilojoules per mole times 4. Why times 4? Well, for each water molecule, there are two hydrogen-oxygen bonds, or two oxygen-hydrogen bonds, however you want to phrase it. And we make a total of 2 waters. So 2 times 2 is 4. And that gives us our multiplier, which gives us a total of 1,852 kilojoules per mole. So our input, basically what we're going to have is we have our delta H is going to equal the sum of what we're putting in minus what we're getting out. So it would be 872 kilojoules per mole plus 146 kilojoules per mole minus 1,852 kilojoules per mole, which gives us a total of negative 834 kilojoules per mole. That is the bond enthalpy for the formation of water. Let's look at another example. We're going to use the same chart. So I'll clear that up. Okay. So we're to estimate the enthalpy change for the combustion of methane. So what does the combustion of methane look like? Let's put this up a little bit for now. Well, methane is CH4, and combustion is always combining with oxygen and yielding carbon dioxide and water. And let's put the coefficients to balance this out. That look right? I believe. Okay, and then we've got our bonds that are broken, which would be a CH bond and an OO bond. So let's take a look at our CH bonds. CH bond is up here, and our OO bond is over here. So let's clean that up a little bit. 413. I'm going to leave out the units for now for simplicity's sake. And there's 4 of them because you have 1 methane, 4 hydrogens connected to an oxygen, 4 hydrogens connected to a carbon, 4 carbon-hydrogen bonds. So there are 4, which gives us a total of 1652 kilojoules per mole. And then, of course, oxygen. Same as before, except now we have 2 of them. So that's still the 146 times 2, which is going to give us 292. Then we need to look at our bonds formed. We have an OH bond formed, just like last time. And in fact, we can use the number that we had before. So for OH, we had 1852 kilojoules per mole. And now we have to look for our carbon-oxygen bond, which is right here. 358. So carbon-oxygen is equal to 358. And there's 2 of them because you have CO2. Okay, so that brings us, bring this back over here, a little easier, a total of 716 kilojoules per mole. So what does that mean? Well, we've got to take the bonds that are broken and subtract the bonds that are formed. So bonds that are broken, 1652 kilojoules per mole plus 292 kilojoules per mole minus 1852 kilojoules per mole minus 716 kilojoules per mole. All in all, that gives us a bond enthalpy of negative 624 kilojoules per mole. And that's how to do the bond enthalpy calculation.